actually a Queens College alumni. I studied on the finance and economic side, but I always had, passion for the tech space as well. When I was at Queens College, I was introduced to Ying, and I launched a startup with a few of my colleagues at Queens College in my senior year called Fix Me. And the incubator actually allowed us to have a year of space within the incubator. For those of you who have not, checked the incubator, I highly suggest you go there. They have great resources, especially for anybody who's thinking about, either launching a startup or, just learning more on the tech side. So the reason why we're here is that Sheikh and I, we run a IT institute called Transfotech Academy. Now, Transfotech, we offer a few different batches such as QA training, BA training, cybersecurity, artificial intelligence, and we are also going to be introducing other trainings as we go along, such as RFP. In these 3 days, we're going to try to consolidate and really give you an insight into what QA engineering actually is and what they do. Per our institute, what we do is we have a 6-step process, everything from training to hands-on labs to internships and to actually resume building and helping all of our students that come through our institute to actually get jobs and placed in different industries. We have placed, professionals in various companies such as Accenture, Google, Morgan Stanley, Saks Off Fifth, Goldman Sachs. So we have these connections and build basically QA engineering and allow them to take part and work for these companies. Now, before I move on, I know we have we kind of want to break the ice. So if anybody here wants to go ahead, turn on the camera and just introduce themselves.
I worked as a senior application system analyst for years at the University of Texas MD Anderson Cancer Center, but I've been out of the workforce now for about a year, over a year, and I'm trying to get back into the workforce, and I really feel like I need to enhance my skill set. And quality assurance testing is I see a lot of that in a lot of the job descriptions that are out in the market.
Yeah, welcome, Deborah.
Thank you.
Anybody else would like to introduce yourself?
Yeah, good afternoon, guys. My name is Kenneth. I'm a student at Queens College.
Hi, Kenneth.
I study computer science.
Hi guys, I'm Mohammed Reza.
Hi, Mohammed.
I'm a Queens College alumni. I graduated in 2005 in accounting from Queens College. Last couple of years, I've been on off with the jobs. So one of my friend introduced me with the QA testing. Mm-hmm. So I'm very interested. I was actually doing study by myself for a couple last years. So I thought someone on Facebook actually forwarded me this link. So I was like, okay, this is interesting. Let's see. Okay. So here I am.
I'm sure you'll get a lot out of it. Welcome.
Thanks.
Hi. My name is Aruj. I'm currently a student in Queens College. I'm doing computer science. And I just want to learn more about in tech field so I can get a job easily.
Excellent.
Yeah.
Welcome, Aruj.
Thank you.
Yeah. Yeah, hi.
Yeah, right now I'm the QC student. Mm-hmm. And doing the computer science over there and just wonder about the QA. That's why I'm here with my friends.
Okay, that's cool.
Mm-hmm.
I think we have lost Abdul for a moment. Abdul, the gentleman who were talking to you guys a few moments ago were also one of the director of Transfotech Academy. I'm sure he'll join soon. This is me. It's a privilege and honor that I'm able to talk to you guys. I'm also from Queens. I'm the founder and CEO of this academy, Transfotech Inc., Transfotech Academy. Under Transfotech Global is the parent company. We do a lot of trainings, like Abdul was saying. We do training on QA, that's one of our core training. And then we also teach coding, Java, Python. We do teach cloud and cybersecurity, pretty much all these modern technologies that we are interested on. I do have a very great corporate experience. I've worked for many of these companies: Accenture, Capgemini, IBM. I worked for a couple of big banks, Chase Capital One. I worked for some of the government agencies as well: DHS, USCIS, Federal Reserve Bank, and so on and so forth. So last December, I quit and I started taking classes full time. I decided to help many of you who wants to make an IT career. So that's why I'm here, and some of my experiences. So again, I would like to thank Queens College Tech Incubator and Ms. Young for putting this together. I think this 3-day session will be a live session. You will take a lot of things away from here. You'll learn about the modern software industry, what tools they use, how they produce software, some of those industry insight, and we'll also, because it's a 3-day session, at the end of the third day, we will help you to put together your resume. From some of your introduction, I know I can easily sense that many of you are here to actually to get a job, not just learn the basics of QA, but also to get a job. And we will take it all the way. We have a very great resume builders, professionals, and also we have great recruiting team. Also, a lot of corporate connections. So with Tech Incubator, we'll work together to help you not just learn, but also to get a job after that, like I was saying. So these 3 days, let's make it conversational, okay? I know that I will give you lectures. I have slides ready, but then also, if you have a question, you can ask me. Every 15 to 20 minutes, I'll stop and I'll give you an opportunity to ask question. And every question is good question. We're not judging anybody here. I think I am here to give you all I know, and you're here to learn by asking questions. So primarily, we are here to learn about QA, right? So QA comes under software development process. It's not an isolated work like QA engineering. QA stands for quality assurance, but it's part of software. It's embedded into software development. So we'll learn about that, how software gets developed, right? And then there is an old way, a new way, and modern way. We'll learn about that, and that will help you to learn about modern development, and that's what the industry is looking for. There are two popular models, waterfall and agile. We'll learn both, but we'll mainly learn agile because that's kind of the popular way. I would say 80% of the corporate industry, they follow agile software development model. So that's what we're going to learn. I'm sure you will have a lot of questions. And then we'll learn about a software development team, how they roll, what they do. Roles and responsibilities are very important. Some of you said that you have some experience in business analytics, maybe some development and QA. So we need to know how they kind of work as a team. And then very importantly, we will get to our hands dirty level, and we'll learn various different tools that we need to manage different artifacts when we produce while developing softwares. You'll know more as we go deep in the class. Again, like I said, let me start, and it's going to be conversational. Every 15 to 20 minutes, I'll stop, and you can ask me a question. So the first thing I would like to talk about today is the software development life cycle, because that's very important. Regardless, you become a QA or BA or a developer or a cloud engineer or an infrastructure engineer, you need to deeply understand software development life cycle. How does it work, and what are the different things that we do? So, I'm going back there. I'm coming back to that slide. Software development life cycle has 5 or 6 different stages. In every different stage, we do certain things differently. First and foremost, when software development starts, we gather the requirements. We collect the requirements. From who? From the client itself. And we kind of write it down. So this is when we call the first requirement gathering level or stage or phase, whatever. So normally we need a guy called BA, business analyst, who comes into that level and who start collects all these requirements from the client and write it down. So there is a certain way and certain format and certain template that they use to document those requirements. If you ever want to be a business analyst or business system analyst, that's kind of your role will be to write those, gather those, understand those, and write those requirements. Where do we write those? In a tool called Jira, which eventually, tomorrow or day after tomorrow, we'll show you how to gather those requirements in Jira tool. And that's what industry is looking for. It's not hard. It's very easy. It's about your writing skill and a little bit of learning. And then the next level is analysis. Once team gets all the requirements of the software, that gives them a visibility that what kind of software or application they're going to make. Let's say you're making an e-commerce software where you want to sell products, right? It's about getting that analytics done and understanding of the business. And as far as the analytics, then you're going to design that software. So design is kind of the next stage. And then, in a software development team, there are designers who will design that. We'll take a look in a moment. And then the actual thing starts with coding. Now you have the requirements, you have done your analysis, you prepared a design. Now what next is development or coding, and that's where all the software developers start writing codes, right? How many developers do we have probably in a team? A multiple, a front end, back end, service developer. So there are multiple developments. We'll take a look also. So the development goes on, and then the testing comes. Software developers don't just develop a software and give it to the client. If that was the case, no software will work properly. Software will have defects because developer makes mistakes. They're human. If you know the coding principle, there is no Superman or rockstar coders, because if you put an extra dot, your entire application might not work, and nobody can know that where the problem will come from. So by nature, developers make mistake, and so the testing is very important because we need to find that error, mistakes, or bugs before it goes to the client. So that's why this testing, this is where we as a Q engineer come in the picture. So to find the developer's mistake, right? Once we do all kind of testing, which we'll talk about more in a moment, once we find all the defects, we send back to the developer for fixing it. And it comes back to us. So testing and coding, this kind of thing goes in parallel, right? And then once there is no defect, right? We QA engineers, we come in here and we check the quality. We test that whatever code developer has written has no problems and no errors. Once everything is good, then it goes to deployment. Deployment is the kind of a last and very important stage of software development, because this is when we actually deploy the tested code, the purified code to production. What do I mean by it? So let's say you work for JP Morgan Chase, and they have chase.com. It's kind of live, right? Live right now. Their end customer can go there and do transaction. But if you are also a developer at JP Morgan right now, you're not working on the real life, production server. You are working on a separate environment for the developers, and then testers will test on a separate environment. So while you are developing in development environment, and then it comes to testing, you also have a separate sort of environment. You do your testing. Then who's gonna take that purified code from testing to production? That's called deployment. So that's also part of testing, which we're gonna talk about the modern testing in a bit. But just keep in mind that deployment is also a big chunk of software development process. Now, to do all of these different things, right? It's not easy. Look, it's various different work. So we need a team. We need a team of army to do it. So who are the different roles? Let's take a look. So this is how a software development team will look like. Every one of these guys are necessary to develop a software. Business analyst is the first one, like you said, who will help gathering the requirement, following a certain way, depending on what software development model you follow. There are two models, which we'll talk about it. So we need a guy who's BA. After this course, you might be a BA, might be you are good at communication and you're good at writing, and you could be a BA, right? And then the next thing is UX designer. We need those guys as well, because who's going to design our softwares, right? If we don't have UX designer, someone has to draw, design the logo, how the web page will look like, things like that. So a bunch of guys, designers, and then we need developers. Now these developers are actually the coders, and then we need QA engineers. That's us. Now, since this bootcamp is about QA engineering, I would give you a little bit of more insight about QA engineers. There are 3 or 4 different types of QA engineers that are needed. Some of them are really testing the front end, the website, the piece that you can see. We also call it graphical user interface, right? I'll give you an example here. This is Amazon. They're I don't know how many billions right now. They just keep going up every day. It's hard for me to keep track of them. I think they're $600 billion company just out of this website. They don't have a physical store. They don't have any employees to manage this entire business. They're purely online. But what they do need a tons of QA engineers to make sure that everything is working every day. Nothing breaks, right? That's what we do. So think about it. I mean, this is what you can see, right? In order to go to Amazon, you just need an URL. You open a browser and you hit Amazon.com, right? If I do it right now, what just happened? Like all the data, pictures, images, everything came, I can see in my computer, but then I didn't have it in my computer. It has to come from somewhere else. So there are multiple layers, right? Not just this, the front end. We call this a front end, or we call this is GUI, graphical user interface. So we need testers and developers to just manage and maintain this front end and develop this front end also. Is that all? No. Like I said, this Amazon has a server, right? A server somewhere in their headquarters. And the server room, I would like to show you. I'm sure that you have seen server rooms before. We all seen somewhere, maybe in movies or real life, we have seen rooms like that. This is called a server room. All this big corporation has a server, and these are giants computer, and then there are databases, right? Oracle, SQL Server, and in there, all the data are stored, right? But how do I get it in my computer from Seattle? So there is a communication that's happening. My browser talks to this server. So someone has to also develop that. Someone also has to make sure that this communication piece is working every day. This communication piece called web service. So we need testers for that. So that's kind of a back-end tester. So we need front-end testers who will just test this front end and make sure that everything works, right? Make sure that if I look for an iPhone here, I would get an iPhone. That's called functional testing, that my application is functioning properly, right? Let's say I want to pick the first one here. And I want to add this to my cart so I can buy it. When I click add to cart, and I should get this window. And I need to verify the price is right. And I will add this to the cart. The moment I click that button, my cart should have that item in it. And if I click in process to checkout, it should ask me for logging in, right? Because I'm not logged in. So this is called testing, front-end testing, which could be done using mouse and keyboards. But there is actual testing, one kind of testing also you need to do by connecting with the server. Data testing, right? The data is right. The server side is right. So there is various different things when it comes to software testing or software quality assurance. That's why eventually we'll learn a lot in next 3 days. For now, I'm just trying to make points here, which is the team. So this is my team, and we need multiple Q engineers, front end, back end, API service, so on and so forth. And each of these Q engineers are needed, and each of them makes very high figure salaries because it requires a lot of technical knowledge, a lot of technical analysis. Not only that, it also requires a critical mind. In order to be a QA engineer, you need to be able to think where the problem will come from, right? You always have to think what's not right. If you look into a room, I mean, normally what I do, if I look into a room, I'll be like, oh, this is the white color, the blue will be better. Or my brain, you need an analytical brain to be a good QA engineer. That's one. Then, and then the second point I wanted to make is this: the whole team, they works together every day, just like that. This is a real picture I took from one of my projects. So QA jobs are not isolated. It's not like you have to, someone just gave it to you and you got to do it by yourself. Not like that. It's a teamwork. Every day, there are certain meetings we do. We normally spend 2 to 3 hours just doing meetings, depending on what methodologies you follow. But it's a teamwork. QA also helps BA, BA also helps QA to do their works. It's kind of complementary to each other's. So you'll have a team like that, and you got to work with them together. And the DevOps engineers are also very important guys who does the deployment and release and stuff like that. You can ask me a question later about that as well. So simple as it is, we have six stages of software development, regardless of whatever model you follow, waterfall or agile. 6 different stages. How we follow those models might vary between waterfall and agile, but the models, the stages are same. First, we need to get the requirements. Then we need to do the analytics. Then we need to design, code, test. Once everything is good, deploy. That is the same process. Now, to do so, we have 2 very popular models of software development. Waterfall is kind of traditional, old. It's been there for 25 years. It's great, and then it also has its limitation. So agile is relatively new. It came into the industry about 10 years ago. Every day, even in agile, there are new models are coming. We will talk about some of them. And agile, agile is more popular because it's frequent, faster, more visible, and more defect-free, right? So why? We'll talk about it. Also make a note that there are 2 more, there are quite a few models, but then waterfall and agiles are more popular. And we will only focus on agile because that's what everybody's looking for. But it doesn't hurt to know the other models. Rapid action development is another model, and DevOps deployment methodology is another model that can go simultaneously with agile development. I just wanted to let you know that. But again, coming back to my slide, waterfall and agile, these are 2 top methodologies. A very basic difference. We will look into more agile tomorrow, in our second session. But the very basic difference is waterfall is kind of a large project. These are the stages, right? We get the requirement, we do design, we do code, we do test, we do release. So waterfall, if you drop water from the top, it just goes downward. Water doesn't go up. So, waterfall is kind of similar, right? It goes from one stage to another. It can't go back up, right? Let's say you are developing a software like Amazon to do an e-commerce software like Amazon, right? In order to do that, very first thing what you have to do is document all of your requirements, right? Like how the logo will be, how many products people can buy, what would be the credit card that you want to process, whether you want to do PayPal or you want to do whatever, right? All these requirements. So in order to build a site like that, there are tons of little requirements that needs to be written. Now, if you follow a waterfall model, you need to get these requirements documented first, and then you can jump onto design. Once you're making the design, you have to design the entire software, right? You have to design the entire software. I'll give you a real quick example of a software design. This is a software design document. This is an app that I have worked for NetJets. NetJets is one of these private airline companies. It's just like Uber for rich people. If you call a flight, a plane through your apps, the plane will be here at LaGuardia Airport, your next airport in 15 minutes, sort of things like that for really rich people. So I was one of the guys who was working on this project. So before we start actually developing the apps, we designed this. And this is a design document, a wireframe. And this is what done by the UX designers. So it'll look like that. All these different features that we want within that application are listed out here. If someone forget the password, we'll be able to reset, right? So this is how it'll look. And then here, if you already have a flight booked, let's say this is the login. This is the login feature. Let's say you are a valid customer and you have already booked a flight once. Now you are trying to come back and log into this application. If you do so, you will see the right side of the screen where it says your next flight information. If you have not booked a flight and you want to book a flight and you logged in, you will see the left side of the screen. So this is how we actually created this design document. So that actually tells you what are the features, what are the functionalities, basically the implementation of your requirement in a visual looks, right? So that's the visibility you have by doing this design document. So going back, so the point I was making is like in waterfall, if you are following the waterfall methodology, then you need to design the entire application because you have collected the entire software requirement. So you need to collect the entire application first. So this design document has the entire software design. So that might take some time. So, so in waterfall, it's a lengthy projects. So you need to write down all the requirements. It might take a month. You need to design, and you saw that this is a lot of designing, right? Then your UX designing team will work on a month or half to design all of these. And then a lot of review meetings happens. Something client didn't like something. We go back and forth and we design. Then we actually start coding, right? Start coding. In order to complete entire development or coding for an app like that would take at least 6 months, right? This 6 months, what is my QA team doing? Basically, they don't have the application done so that they can start testing. So they're just sitting idle, right? So there are a lot of times that mismatching. Corporation might not keep the QA engineers while coding is going on because that's waste of money. And also, when it comes to, let's say when development is done, when it comes to test, the QA testers are testing, and let's say that they have found a lot of issues, a lot of problems. Something is not working, the button is not working, logo looks bad. Now they cannot go back here and fix it. That's the major drawback of waterfall. Once something is done, it's done, it goes to the next level. So it cannot go back and fix stuff, right? So if you have to go back, you need to go back here. That's one of the major drawback of waterfall. So, you just lost 6-7 months of time already if you catch some problems during testing phase, right? So industry came with this agile concept. So it's very similar, as you see, that we do the same models, same stages, but instead of building the entire software, we develop software in different pieces, and we call it iterations. Iterations are nothing but time box, a time frame. Like every 2 weeks, we would call every 2 weeks and one iteration. So first 2 weeks would be iteration 1, second 2 weeks would be iteration 2, and what we will do, we'll do the same thing but in a different piece. We'll take a little bit of work and we'll design the little bit of work. We would take, we'll just develop that and we'll test just that piece of the software, and we'll release that one piece to the customer. And we will repeat the same thing. We would go for iteration 2. We will get a chunk of the requirements, we'll design, we'll code, we'll test, we'll release. This is how we're gonna do. So in Agile, instead of doing one thing at a time, we get a chunk of the software and we keep doing that. So in a given project like that, which I just showed, like NetJets, you will have at least 24 to 30 iterations. And in every iterations, you do a little bit of work done. And clients loves it because every 2 weeks they get to see some sort of softwares are coming out. Okay, so that's why Agile is more popular. There are 3 frameworks of Agiles out there that we need to learn, but it is more popular. So the first and foremost, if you want to make a career in QA, you need to focus on learning Agile and how corporation practice Agile, right? It's the way I'm showing you is very fundamental, but there are a lot of rules, a lot of tools, a lot of techniques that they follow. That's what they ask you during the interview, like to testify you how good is your Agile experience. So here I'll take a pause. I'll take some questions if you guys have any.
Is there a max time on the Agile life cycle? Is there like how long can that cycle last?
That's a very good question. It depends on the software. You probably want to make an application that's 3 pages long, right? Or you want to make a software like Amazon, right? It doesn't, I don't know how many pages Amazon has. So Agile also gives you a scalability, right? If you are making a software that's 3 pages long, it would get done in 4 iterations, right? Every iteration is 2 weeks, and we only do certain amount of work in the 2 weeks. There is a way of getting an estimation done in Agile. Once you learn more, you'll see. So it doesn't really matter. If it's a project of 6 years, we'll get done little by little. As far as we can take in our plate, we'll take it. So there is a way of doing estimation during sprint planning meeting in Agile. We'll learn that tomorrow, and that will help you to answer the question.
Thank you.
Question?
What are the benefits of waterfall, the methodology of waterfall?
I couldn't hear you. Just would you mind asking that one more time?
What are the benefits of the waterfall methodology?
Okay. Waterfall is good for large project. Let's say that I am building a very large project. Like I'm building an entire system for a bank. Now I know that the requirement, right? The gathering phase would continues 3 months because there's a lot of requirements, a lot of meetings. My business analyst will have to go back and forth with the client and other people, various different departments in bank to have a requirement ready. In that kind of project, waterfall is better because you just want to hire, our corporation just wants to hire 2 BA at that first phase, and they don't want developers, they don't want QA. So this saves money. And then let's say that most of the corporation have offshore team nowadays, right? Let's say that you are a bank, you want to develop a software and you outsource to your entire development into some of the South Asian countries. And you don't need to do QA at that time while development is going on because it's going to be 1 year of development. in that kind of project, waterfall is better, right? Because you don't want to hire QA and be, just be able to sit there and pay money. So that kind of project, waterfall is better. Agile is better when you want more interactions. You want software fast. That's what every industry wants nowadays. Amazon, if Amazon decides to add a new feature to their website, they want that feature to go in the market in next 4 months or 3 months, right? So what they do, they create a team of Agile. They bring everybody together. They bring the designer together, developers, and QA. They call it three amigos. There is a term called three amigos, right? And then they let the whole team work together and figure it out. So the BA will get the requirements in written format, and then UX designer will work with BA every day, because you sit together. In Agile is a practice. It's not just the name of methodology. It's actually a mindset. It's a practice. How you work together, help each other, and keep track of the work and get things done together in a faster way. So BA will help the developer will help the BA. And if you have any question, they answer it right away, because that's your team. So that makes the process faster. It also eliminates a lot of misunderstanding, right? That's a major issue in software development. That's also good for you to know, because in the interview, they ask you the issues and problems of software development, and you should be able to talk about it. Misunderstanding, miscommunication is any major issues of any development, not only software, anywhere. So let's say if you misinterpret the requirement, what happens? You develop the wrong product. What if your QA engineers misunderstood the requirements? They will do the wrong testing, right? End of the day, they will get the wrong product. So software industry really focus in Agile so that they can eliminate all this misunderstanding between different stages. That's another benefits of Agile, because you sit together, you work together, you use the same tool, you can ask questions, things like that. So that's why Agile is more popular nowadays.
I don't know. Okay. Thanks, Sheikh, for taking the time out to come out and talk to us. The question that I have is, how many years of experience do you have using both methodologies? And when you first started using it, did you find any difficulty? Like, what were some of the challenges?
Very good question. I have 10 plus years of experience. I started my first job at 2011, early 2011, I guess. So that was waterfall, right? That was a time when corporation used to do waterfall. Agile first came in and they were trying to adapt it, right? And when you're trying to adapt a new culture, new thing, it's always hard. You don't follow the proper way. You do things wrong, and you feel like, oh, that didn't bring any value. So the old one was better. So it was exactly like that. So I used to work for an insurance company called Nationwide. They are also the largest insurance company in nation. So they actually hired a third-party company, IBM. So they brought IBM in to teach us Agile, right? Not teach us like, how am I teaching you with the slides and everything. It's about Agile is all about being Agile, bringing that mindset. So their consultant came with us and worked with our team 2 months and help us figuring out what we're doing wrong. So slowly, we became Agile. Right. We were doing meetings every day morning at 9:30. We call a stand-up meeting. That's what we do at 9:30. And we answer 3 questions. It's a teamwork. We answer, what did you do yesterday? What are you doing today? And is there anything stopping you or bothering you? Do you need help? So that meeting, if you do properly, which you have no scope to do in waterfall, that meeting helps reduce communication errors within the team. And that meeting, Agile says that you actually have to stand up to do that meeting. You cannot just sit there and do it. So you can YouTube it, the how to do stand-up meeting in Agile, right? That's a meeting that we do every day when we go to the work. That eliminates a lot of miscommunication. So this is how we started. And then a lot of corporations were looking for it. And then there is an Agile certification came in. Later, a couple of years later, it's called CSM, Certified Scrum Master. or PSM, Professional Scrum Master. If you can pass that, that's a great value add to your resume, right? Even if you are becoming a QA, you can pass the Certified Scrum Master. I'm Certified Scrum Master. I probably have to renew my thing. I've done it 4 or 5 years ago. But so Scrum Alliance, Scrum Alliance, it's a global organization who provides this certification. And if you have it, it looks like that you really know Agile. So then later on, industry moved on. A lot of smart folks came together and they came up with 3-4 different style of Agiles. And we call it Agile frameworks. The industry got matured, right? And then they came up with Scrum. Scrum is one model. And they came up with something called Kanban. Some people didn't like Scrum, or were like, oh, that's too much. So they started doing Kanban. Now, industry has, there are more, but industry has these 2 types of Agile practice called Scrum and Kanban. We will take a look at that tomorrow. I would give you very in-depth information about how industry practice Agile, how industry practice Kanban and Scrum, both model of Agile. I would really want to say this, right? Agile is the key of getting a QA job. It doesn't matter how much programming you know, how much technical knowledge you have. It's always, you can talk about Agile, the beautiful things of Agile, the mindset of Agile, what are the different things we do. You can explain some of the frameworks of Agile to impress during the interview time. And that's a killer, right? Agile. So that's what we're gonna take a look at that tomorrow in details. I'm going to take one more question and I'll go back to some of the topics.
What is the requirement for Scrum certification?
You just have to study and you take the exam at the Scrum Alliance. You need to register for that. There is a fee of $150 if I'm not wrong. It might went up because I took it way before. It's an online based exam. And they ask you like pretty much 35 questions and you need to get, I think, 85% mark to pass that.
Do we have to have like, work experience or something like that?
No. You can take a course. There are a lot of institutes and even online people provide those 3 days course. You can even buy a course on Udemy and do it.
Thanks.
Yeah, that should be the first one. If you want to make a career in software development, either development, UX design, or QA or DevOps. These are the 4 or 5 different roles, right, that I talked to you about. Scrum the first one that you should look for. That has some value. And it's easy, it's not hard. So today is a lot of information about theoretical information. Tomorrow we'll take a look in deep in Agile. So here is a difference, another difference between a traditional team and Agile team. In a traditional project management team, what happened? We have a project manager who manages everything. We know that guy's PMP, project manager, and then this guy will set the direction of the project, monitor, mentor, and all the team member will be reporting to that guy, right? And that is not worth. So what happened, decisions coming from one guy and then it going downward. If he makes a wrong decision, the entire team suffers. And if he makes a wrong decision about a technical development or documentation, then entire teams, provides the wrong documentation downward. So you end up making the wrong product. So there is an error itself within that. So versus Agile team, we call it self-organizing. Nobody reports to anybody. Everybody is the same. That's kind of mindset we have while we work with Agile. We have a facilitator. We call it a Scrum Master, and the green guy. Scrum Master is a role in Agile. It's kind of like manager, but you don't really report to that guy. He's your friend. He will facilitate with all the information that you need, help you get your question answered, and facilitate meetings and things like that. So he's your leader, right? So the Scrum Master. And then everybody is equal. Everybody is cross-functional too. Everybody helps everybody. you do the same amount of work that this guy does. And now you're going to ask me like, how do you really measure that? That's the key of agile. You'll see tomorrow. There is a way of measuring how much of work you are going to do these next 2 weeks by doing some estimations. So agile team, every task that they do, they put a time on it. They say, okay, this is the task of 3 hours. This is a task of 8 hours. They don't do exactly this way, but they do some sort of relative estimation. We'll see tomorrow. So the point is that this guy cannot complain that I work a lot of things and the other person doesn't work. Everybody takes the same amount of work for every week. And everybody means developers, QA engineers, release engineers, BA, product owner, whoever the roles, right? And these guys, Scrum Master, are just there to help everybody facilitate meeting, get their question answered. He also gets the same amount of work. So that the rule number one is everybody got to help everybody. Now, if you're a QA, if you don't have much work to do in these next 2 weeks, can you also help BA to write some requirements? So something like that. I mean, agile is cross-functional and self-organizing. Okay, so that gives you a little bit of insight. Now I'm gonna take you to some of this technical understanding of software architecture. End of the day, we will be QA engineers, and QA engineers are software engineers, right? Now, what you do QA, you do software, right? Testing. So we need to understand how many different types of softwares, you know, because you need to QA them, and not every kinds of softwares are same by nature. They're different, how they communicate, how the data are stored, how it looks. All these things are different. So we really need to know. So there are 4 different kinds of softwares. And then look, I don't call software anymore. I call application, because that's what everybody calls in the industry. Softwares are like non-software. The word software are for non-technical folks. When you get a job, you will hear that everybody's calling application, not software, but it's the same thing. So desktop application is the first kind that you install, a kind of software that you install in one computer. It just stays there. It doesn't talk to any other computer. Example, Microsoft Windows. You get a CD or you download it from online, you install, it just sits there. Another example, maybe Microsoft Office, Microsoft Word, PowerPoint. These are all softwares, right? Application. So this is the first kind. We don't really worry about it too much for now, right? I don't think you will get a job where you have to test the desktop application, but just to let you know. And then the second kind we have is client server application. That application that sits into one machine, you need to install it. You need to install that into one computer, and it talks to a server. It exchanges informations, but still it could be installed in one machine. It cannot be installed in multiple computers. And it not necessarily that you always have to install client server application in a computer though. You can install it in a POS machine. You can install it in this car little, you know, the gas station machine. Now, this is a computer, by the way. This is a small computer. It has a microprocessor, a mini chips that talks to your bank, right? That's why if you swipe a card that doesn't have money in it, it declines you. It talks to the bank in a real life. So it has a computer. So this kind of application that sits into one computer, a little computer, and talks to the bank, talks to a server called client server. I'm sure you also don't have to worry about that too much. You have to worry about these last 2 kinds of softwares, because that's what industry needs to operate their businesses. And that's what they're gonna pay you high salary to make sure that these 2 kinds of softwares are working every day and there's no defect. First kind is web-based application. And the second kind is mobile application. I don't have to explain to you, you all know what are they. Facebook.com is the web application. Facebook app that you download from App Store are mobile application. But Facebook needs both. Same as JP Morgan Chase, same as eBay, same as any other company that operates business in USA, a big business, PayPal, whatever, they would need these two, web application and mobile application. And that's what you're going to put focus on. What's on web application? It requires a browser to browse, right? This is a web application. What do you need? You need a browser. Either it is a Firefox, Google Chrome, Safari, whatever, any browser you need to be installed in your computer. And then you need an URL. This is an URL, right? This guy is an URL. That is the address for Amazon's server. And that's why when I click here, it doesn't go to eBay, it goes to Amazon. It knows what server to go to. The communication piece, I'm coming there. But the point I'm making, when I click this, it knows where to go. So that means it's the address for the server, right? And we call that URL. Behind this guy, Amazon.com is actually an IP address that is very unique. It looks like 110.222. You have seen some IP addresses before. So that's the address for the server. Facebook.com is the same thing. So in order to, develop a web application, first you need an URL and you need a server. That every time you browse that through a browser, it will go to the server. So first thing first. Second thing is like what you need to understand here is the architecture behind a web application. Like you said at the beginning, this data I didn't have this data. It came from somewhere else. Like now I can see the pictures, this text, this Alexa picture, a fan, all these are data. Pictures are also data that I didn't have. It came from somewhere else. Now if I go for iPhone, I clicked here. Now my data has changed. Now I can see new pictures. I also didn't have it. That came from the server. Now, so the data is going back and forth. That's the most important piece for you to understand, the architecture behind a web application. Because if you get a job at Amazon and you'll be responsible for testing whether it works or not, how many different things do you have to test? Now you have to test the front end. You have to test that communication. And literally you have to go to that server and see if the data are there. So there is 3 areas of testing. Testing the front end, testing the back end, testing the service, the communication. So just going back to my slide. Okay, so let's see how the web architecture works. This is what I've been explaining. So you have a browser and your computer is connected with the internet. Once you go to a web application using an URL like Google Chrome, like I did, it connects with the server right away, right? And once I'm searching for any information, let's say car, it talks to the server. The question is how. So this is the server, and I'm coming back to this slide. So whenever I click, something goes here called, it's an HTTP request goes in using the internet. It goes to the server asking for information. So we call it a request goes. And then server put together response for us. So response comes back into my browser with the data I've requested. What do I mean by that? If I look for a pen, if I click right now, a request, an HTTP request from my browser will go to the server. And server will receive the request saying that Sheikh wanted the information about all the pens that you have in your database, one by one. server will receive the request and read that what I wanted. Then based on that, server will immediately put a response file back with all the data the server has in there and send it back to me. Back to me means back to my browser. Boom, done. It came from the server. Now my browser received all of the information from the back side of the browser. I don't know, it seems like a lot of IT, technical people are here, but somebody might have not this knowledge. So if I go right click on a browser, there is a back engine that you have probably not seen. This is where it comes. Okay, see that all the data is there. Here is the data. So let's say that if you want to see that picture, see that this is the line of the code that responsible for the picture, and it says IMG stands for image. If you look for a text message only, let's stop by pen line point. See that within the back engine, here is the data came in from the server and got inserted in the back engine, and my browser knows how to display nicely for you. That's what browser does. Browser gets information in the back engine, in a very weird way, because server sent all of the information within a file, right? It's called, we will take a look. It's called XML or JSON file. Your browser is not showing you that file. The browser actually got rid of all unnecessary information and just showing you the necessary information you need to see as a customer in a nice way. That's what browser does. So this is very important, right? That communication piece. If there is no communication, none of these software will work. And that is called web service. It's a process of communication, excuse me. It's a process of communication between application and the server. Browser sends request for information to the server. A server receives the request and processes it and send the requested information back to the browser. So your phone do the same thing. This is not the case of just a web application. Your mobile apps also do the same thing in a different way. Now, question: who creates it? Now we are thinking from the developer's point of view, or like we are developing these, right? As an engineer or as a software development team. Now, question is, I understand someone creates the front end, so we need front end developer and we need front end QA, which is easy, right? Anybody can create this front end. If you know this HTML, CSS, developer from the development side, you can create this front end. You can have a couple of testers who would know how to test all of these, and that's fine. Now, front end is covered, but who is creating the back end like this, right? In order for my software or browser to be able to pull the data from the server properly, what do you need to create is called APIs. APIs stands for application programming interface. We have heard about APIs, right? APIs are like the doors within a program. Let's say you have built a house and that's your program, right? Your program needs to automatically communicate with others. That means information needs to get out from your program and information needs to come in within your program. If you think about your program like in a house, then you need to create certain doors, because if it's closed, then your program, nothing can go back and forth, right? So APIs, think about it, it is the door of a program. If you want certain information to come from the server, when you write a program, you need to create a bunch of APIs, right? So if you're looking for information, let's say this is your program. Again, I'm gonna go right click on and click inspect on any Chrome browser. I scroll all the way up here. You see a lot of codes are written. This is your first line of the code where it says HTML. And HTML has two major pieces for your program. This is your entire program. Your HTML headers, you can expand that, and a lot of things goes into the header, and then HTML body. Body has the entire body of the application. So this is your program. In order, let's say someone has created it, right? Of course, someone has created this program, meaning that some developer has written all this code and that produced this beautiful Amazon front end, whatever graphical user interface, what we can see. Now, if you don't create APIs, then Amazon wouldn't be talk with the server. Now, if I look for pen, let's say this is a house, and if I look for pen, the pen's information is coming from a server through a door, right? And someone has just created the door in my house. So now I can tell Amazon when I look for pen, when information is coming from the server, get the door open automatically so my browser can receive it or my house can get those data. Something like that is really complicated, but we'll explain more in last class. So APIs. For now, just understand that in order to these entire infrastructure work, we need to create some doors in our program, and that's APIs. So we need developers, right? We need developers to write code and create those doors because the program is code. The doors will be also code, right? So they will write certain codes to create these APIs. Now, do we also have to test it? Yes, of course, because they're writing code. Again, they might write wrong code. They might put an extra dot and entire API will not work. So also we need API testers or web service testers. You know, APIs is that particular door, and web service is basically the the name of this communication, right? The entire system of this communication we call service. Some sort of service given, data exchanging service. So point I'm making, you also could just become an API testers, API QA, and start making the same amount of money because corporation needs different testers, someone to test the front end and some people to test the APIs as well. Now, can same person do this both kind of testing? Yes, if you become really an engineering level resource, you learn both, then you will be able to do both. But in the industry, there are two different roles. Both are QA, right? And that's not it. You need somebody to also go test actually the server, not the communication, not just the front end right here, but actually the data. And that is called back-end testing. Some people know, some people will learn the SQL queries, how to work with databases, servers. They will become back-end testers. But you need all three in a software development thing. So you can learn either one of them. But however, you know Agile for all three. If you want to become a QA, you need all three. You need Agile for all three. So Agile is a must thing to know. And then you can grow your technical knowledge in the front end, or you can grow your technical knowledge more at the API testing or web service testing, or you might be a guy who loves to deal with data. So you learn SQL, you learn about servers, you know how to connect in here and do verify the data and things like that. You can also become a backend QA. Or let's say you want to learn all of them. Yes, you can. You can learn all of them and become a QA like engineers, right? And industry needs that. Industry needs the lead type of resource who knows all 3-4 different areas. And that would be some of my intention to at least give you as much as possible within the next 3 days from an engineering 360 level vision. And from there, if you need more help, we're always there to help. So I'm sure you have questions, and I'm going to open up for second sort of questioning.
have another question. Sorry about that. This is Jonathan. If we want to enroll in Transfotech Academy, is there a fee to pay, and what does the coursework have? Like, are there any projects, assignments that we work on if we want to like further this?
Well, sorry, go ahead, finish it.
No, I'm good. You're good.
Okay, so we have great things coming up. You will hear from Yin soon. Maybe we will explain a little bit of about the future steps on the last class, but I can tell you that far that we are actually doing a lot of the things for Queens College folks for free, and we are coming and helping you. We have a bunch of things in our pipeline. But also, if you want to take beyond and above, we always have a course. Not only that, if you need some help, like with recruiting, resume building, we do that for free. So we will talk about it, I think, and the last class.
Okay.
Will that be okay? Yeah.
Yeah, that's good. Thank you so much.
Perfect.
Hi there, this is Sarma. Could you explain the different APIs and, for example, REST and SOAP, and how you apply it to which door fits with which building? Thank you.
Sounds good. Cool. Sharma has asked a very, very important question. A little bit of little details, little technical, right? APIs, right? Creating doors and how do I say? Okay, I got a good example for you guys. If I want to send something from here to India, what would be the procedure? I need to, let's say I want to send a letter, or I want to send some data, some objects, whatever I want to send. First, I need to package that, right? Maybe it's a letter. I want to write the letter, and then I need to put it into an envelope. And on top of the envelope, I need to write the name of the receiver, address, and then at the right corner, I need to write down sender's information. It's my information. And then this is the way that you write the envelope. And there are some models already define how you write the envelopes. Now note, British writes a little different than American folks. American writes a little different than British. How you write the envelope, right? Do you write the sender's information on the top, or receiver's information on the top? Regardless, these are two different formats of writing an envelope. It would go to a post office regardless, and the postman or the carrier, whoever, would carry that to a different place and drop it. That's the process. So now think about that. How do you write an APIs? What is an API? It's a format of exchanging data from one place to another, right? First, you need to write the address of what server it's going to go to. And I told you the URL is the server. So first, the server address. Then some protocols to form whatever. And then you need to put the questions, because it's a request going out. It's something like, give me all the iPhones information, or give me all the iPhones information that less than $300. So that request needs to be written within your API. And then you will go. So, and server will receive it and put the same format, right, of response back to you. So basically, there are two different ways, like British and Americans, like that example, there are two different ways you can write that API file, which is SOAP and the REST. These are two different protocols. If you become an API developer, or you want to become an API tester, a web service tester, you need to learn about these two protocols, right? They're very similar. They do the same thing. Like you said, this is British versus American style of posting a letter to the post office. REST are the same. So REST, I would focus on REST because that's the newer version of doing API. And like Agile, I would say 80% or more corporations do REST APIs. REST APIs are faster, precise and faster. Okay, so I would want you to focus on REST APIs. Now, REST just is the name of the protocol, REST or SOAP. We know that by now. So what is actually REST? What is actually how developers create those APIs? They create some sort of file called XML or JSON. What goes, whatever protocol you follow, REST or SOAP, what goes? Some sort of file goes, right? Again, think about logically. If I want to type pen for iPad, if I click this guy, we know that a request will go in and the response will come with the information. What actually goes is a file called that, that not one file, it could be XML or JSON, depending on how developers has developed the APIs. That's the difference. There are two types of file could be used to carry this information, to send the request or to receive the information. So JSON and XML. So you have to either use XML or JSON. XML will look like this. And who decides that? Depending on, first, you need to decide whether you're going to use REST protocol or you're going to use SOAP protocol. Let's say you want to use REST protocol, right? That's the first thing. Second thing, you need to develop your APIs by picking either one of these model. JSON file, do you want the JSON file to be your carrier of the data, or do you want XML file to be the carrier of the data? Most of the companies nowadays use JSON files. And XML and JSON, learn about it. These are both two different types of file. Like Excel is a file that carries information, but it's very heavy. JSON and XMLs are very lightweight file. And it's commonly used for carrying, exchanging information. And it looks like this. You see that the things are in black. These are informations, and then file has tags. When it goes from your browser, let's say I'm developing an app, it has REST protocol and XML per se right now. So what happened when I click pen for iPad? First thing happens, my backside of the browser calls an API. The API has already been created by the developer. It calls an API and it gets my input, user input, create a file like that and put that input in there. If it's XML format. If it's JSON format, then it creates a file like that and puts my input in there. The Sheikh is looking for this information. And then it creates this JSON or XML file. And then it sent that file to the server. So this file goes, actually, a file goes as an, HTTP request, REST request. A file goes and browser opens it, and browser knows how to read a file like that. It'll be written like that. The browser knows. Browser will just read this. Sheikh is looking for pen. And browser will also send same file, XML or JSON, and look like this. Now, if it's JSON, look, there's a tag, and you see the name, gender, age, address. So this is information. It's actually information comes like that. So JSON or XML will come with the information and gets inserted in here. And your browser will get rid of all these unnecessary information, unnecessary tags, right? You see that greater than the tag name and slash tag name close. Browser will get rid of all of these tags and just grab these informations in the black, that actual information that came from the server. And then we'll do the work to just display that information to you. So this is how API works. It gets called, a file goes with the request with the information that you asked for. A response comes with the response with a lot of information. Your browser receives it, and your browser gets rid of the unnecessary information and shows it for you. Now, what does that mean to you as a QA tester? Maybe as an API tester. You need to learn, first you need to learn this protocol, REST protocol. Can a corporation use both? No. Either they're going to use REST protocol or they're going to use SOAP protocol. Most of them use REST protocol nowadays. So it's a safe, just to be on the safe side for you, I think learning REST would be the best thing. Then you need to learn how XML files are structured, because if you don't understand these, the tags and things like that, it would be hard for you to do API testing. Oh, and JSON, I would highly recommend that learn both, because it's really 50-50 or 60-40. You don't want to miss a chance. These are two different files, and I can give you a great website to learn it from. w3school.com. All right, let's see here. Okay, it's really good for the beginners for learning different tutorials. You see that you can even learn SQL. Like I said, if you want to be a database engineer, like in the backend engineer, you really need to know SQL. But let me answer your question first. XML, right? Type it and you see the entire tutorial for XML, and it's amazing. It just has everything in here: syntax, how to write those XML files. See that? This is the first structure that you create, and it's actually tell you how to do step by step. So I think going through this tutorial, spending a couple of days on it will get you started on XML. Then you should do JSON. I'm gonna copy paste this URL in the chat room so you can have it later. Yeah, so I just gave it to you in the chat. I think you guys can bookmark that and start learning from there. What I would, I would highly recommend learn SQL first, because that's where there's a lot of requirements comes in. SQL is it stands for a structured query language, but it's the thing that you need to communicate with the server, not through the API, but directly if you connect to the server. Let me show you here. Like I said, somebody has to do the backend testing. It actually connects with the server and pull the data. So SQL is very easy to learn. It's not a programming language. It's called query language. It's very plain English type of thing that by learning these, you will know how to connect to this database and how to pull the data. Let's say, all right, I'll give you an example. Amazon, right? Amazon has all their customers' information, and their customers are all spread it throughout the world. And if you want to just see that, if you want to just pull the data from their server, that whoever just shopped on Amazon on last 3 days, and just in New York and just in Queens. See, you are filtering down your information. How do you get that information from Amazon? That's when you learn SQL. And SQL give you ability to filter your search, and you will directly connect to the server where it has all the information of the customers of lifetime. From there, you will know where exactly the information of last 3 days, and you will know that how exactly do the filter and get that information that you're looking for. Let's say that you want to get all the males or female customers information that are located in New York. So that's a filter. So you wanna get all the informations of your customer whose age is between 16 to 23. That's a filter. So by learning SQL, you will learn all of these filtering. And why do you need that for testing? Because this is how by running different queries on the database, you will check the velocity, and not the velocity, the diversity of data, the correctness of data, if the server works, if you are able to get the right data, if the data are stayed at the right table, which is the right space, you learn about table layer. So things like that. In order to do database testing, you need to learn SQL, and that is very fun. That is very easy. And W3 School has an amazing tutorial for learning SQL. And just learning these and learning Agile, you can get a QA job. If you are good in communication, you can definitely get a QA job. And you need a good resume, of course, as in backend testers. So I think this is a good starting point for you to start learning SQL. And I hope that Sharma, did that answer your questions? Because I kind of jumped around into a different topic.
Yeah, it was a good explainer. Thank you.
Thanks. Yeah. So, I mean, we are almost toward the end of today's session, and it was just a ground setting and a lot of information. I know eventually we'll be able to connect all of those while we were doing one project, maybe the third day, or writing some test cases and things like that. Now, let's have some more questions, and we're almost finishing today's session. I'm ready to have some more questions and hear some feedback from you guys.
I have questions.
Sure.
Database testing, backend testing, and SQL.
Right.
Both are same thing. I saw like a different requirement has a different different things. Like someone wants to, what is the database testing? Do you have experience with database testing? And someone else, do you have backend testing experience? And someone write just the SQL. So all are same thing.
So first and foremost, SQL or CQL are the same thing. For some weird reason, you're not seeing my screen, so let me share. SQL and CQL are the same thing. It's called a structured query language. Okay. I don't know why it calls CQL, but some people just call CQL, but some people call SQL. There is a huge, half of the industry calls it CQL. So if you hear the CQL or SQL, it's the same thing. Second of all, database testing is the testing that you do with the database, right? Like I just said. This is your database, a server. Or backend testing or database testing. I mean, databases are located at the backend that you cannot see. So these are the same thing. Backend testing means database testing. Okay, but how do you do database testing? Do you actually go to Seattle and go open this database where the database are located at the Amazon's headquarters? No. You need to do testing from your place. Maybe you were working out of New York's office. How do you do that? By learning SQL or SQL. You learn SQL, how to connect to the server from wherever you are. And then you write SQL queries. So this is why it calls SQL queries, right? You write SQL queries in your computer to get different data filtered out from the server to check that whether the data quality is good, data are properly stored, things like that. So these are all same thing. Now, I mean, it's not the same thing. Database testing is a kind of testing, but SQL query are needed in order to do database testing. So SQL is a skill that you need to learn. And W3 will be great help for all of you if you want to learn SQL. This is something like, SQL from customers. And there are examples that you can run, right? I'll give you an example. Let's say there are how do I say it? There's a table called customer. What's table means? It's in space in database where the data are stored, and it looks like that. You see all the customers information are here. Let's say this is a company and this is the customers, all customers information. Okay. As you can see that it has how many customers? Every customer has a customer ID, right? It has 91 customers. And obviously this is a sample database. If you get into Amazon's database and look for all the customers, how many customers Amazon has? Millions, billions, I don't know. It'll be billions customers information. And each one of these represent one customers. And what information do you have in here? Contact name, addresses, city, postal code, country. And you see that I have different customers that are from different countries. Okay. Here is one from Germany. Here's one from Germany. Right? Now, let's say that I want to know why, forget about it right now. Let's say my requirement is as a tester, I need to know how many customers are in Germany for this company. How do I do that? So I'm going to write something like select star from customers, where country is equal to quotation Germany. You see that now I immediately filtered out all these Germany customers information. How powerful that would be. Out of billions of customers, if you know how to write these, and you'll be able to filter out informations, right?
Are there automated scripts being run at night?
This is a good question. Now, everything that I talked about, right? If you want to be a QA, I talked about being, I talked about there are three kinds of QA. Somebody that tests here, right? Every different functionalities that of this front end needs to be tested. And then I talked about being a QA of the APIs, right? That request, response, data comes back and forth. And then I talked about some QAs are just to test here. Now, how you do test depends on various different factors. You can be a manual QA who does all these three kinds of testing manually by your hands, writing queries, by mouse, which I just did throughout the class. Or you could be a very enhanced and advanced QA who also know to do all these three kinds of testing by writing code and utilizing few other softwares that let you automate your manual testing efforts. Why that is necessary? Because that's brilliant. If you can automate that, you can do the same testing over and over and over again. If you don't know how to automate, if you don't have that automation engineer, we call them automation engineer. They're also QA engineer, but they know how to automate your manual testing into automation. If you don't have that practice in your industry, then you will just be able to test it once because you are testing manually. It requires time, resource, efforts. But if you also know how to make that automation, then you just, you create that automation script once to make it make a manual testing automated, and then it just sits there. You can test it over and over and over and over again automatically. And that's where the power is. That's what everybody is looking for. And yeah, so we'll learn more about automation testing in upcoming sessions. And if you can learn that is the killer. You need to learn a programming one. You need to learn two tools called Java and Selenium. And there are a few other tools to become an automation engineer.
Would you tell me what it would be the best path? Because earlier you said it's good, it would really be good to know Agile. That would really be good. So what would be the best path for a person who doesn't have any QA experience?
Very good question. I love it. So what's QA? It's software development. It's part of software development. Now, if you don't know software development, you wouldn't know QA. So what's agile? It's the process of overall software development. You need to know anyhow, anyway, right? Then that's kind of your organizational knowledge. Then comes to your technical skill set, which really relevant with the QA world that you're going to make career for. And that's where there are diversity. First, you need to learn how to test application manually. Automation comes later. Even if you don't learn automation, there are jobs out there, and we call them manual testers. So you need to learn how to do these manual testing first. Manual testing, at least the front end, the graphical user interface. That's what you need to learn first. Then, if you can, you need to learn database, SQL, how to query data. That's kind of a second thing. And I'm talking about learning manually. I'm giving you the steps. Learning this manually will make you become a QA from the mindset point of view. Now you can learn a programming language and take all of these things that you have learned manually. Now you know how to do it automatically, or writing scripts, things like that. That will make you a super, Iron Man engineer, I would say.
So once you actually learn some of this stuff, are there any websites where you can go and actually do a project hands-on with doing some of this stuff?
Yeah, in my academy, we bring on for a 3 weeks internship project. We literally simulate a job-like environment for all of us, all of the students, and they do it. And that's after the course, though. I mean, there are a lot of things. See, it normally takes 3 to 4 months to complete all of these, right? If you want to really become an engineer level resource and learn all of these, so it takes 4 months. So we offer a 4 months long course, and then we bring on for 3 weeks of internship, where they actually work on an agile, Scrum, 2 weeks with the real life tools and things like that. We'll talk about it on the third day. So we might, in upcoming days, we might be able to put together an internship just for the Queens College students separately. And if you need any personal help, you always feel free to reach out to us, right? That if you need an internship, if you don't know where to start from, need some more guidance, I'm always there to help. The entire Transfotech team and Queens College Incubator are ready to help you. So reach out, feel free to reach out. So yeah, I mean, look, this is a lot of things we talked about today, and these are all different pieces. It's hard for you to draw a streamline here maybe, but let's hope for tomorrow, and we'll make way more sense since we start doing, we'll narrow down our focus toward QA tomorrow. We talked about an overall architecture, infrastructure. We talked about the team model. We talked about agile. Tomorrow, we will narrow down our focus that as in QA, what do we do, right? In day-to-day basis.
Anyone has any more questions?
When you are explaining the API, you mentioned the web service too. Does it like two different testing, or it's the same API and web service?
No, web service is it's what you call about that exchanging data and everything piece, right? We call it web service. It's a service. So when we call the testing, we call it web service testing. And API is the programs that developer creates that helps to do web service by carrying data from one place to another. That particular program, each of these called APIs, right? If you hear somebody's calling it API testing, this is the same thing. They're referring to web service testing, basically.
Okay.
Hey, Sheikh. Actually,
yes.
How database connect to the applications? So we got the data and applications. How it's connected each other?
Through APIs.
Through API, right?
Yes.
Thank you so much.
Yeah. So a developer will create an application and then a program. Like I showed you, the Amazon backend, it's an entire program. But the developers will also create the doors of that program as an APIs. Hundreds of APIs. These are doors in your programs. through that door, it communicates, a file goes out to the server, which is the HTTP request, and a response comes in through that APIs. Does that make sense?
Thank you so much. I was a question. This question is too many people, but they can't answer. It's the first time you clear me my basic. Thank you.
Very nice. I'm glad I was able to help. I mean, don't hesitate. We are over. We are 15 minutes over, but I love to answer questions, and feel free to ask many, more questions. I don't mind. But do give me some feedback that how was today's session? Was it helpful? Is there any particular thing you want to know for the next 2 days? Would you like to get a slide after that? Whatever, any feedback will be helpful.
It's great, man. It's great. It's great. A lot of basic clear. A lot of people teach, but they don't clear the basic. Just reading. You did a lot. Thank you so much, man.
No, absolutely.
Also, feel free to type in your questions or feedback in the chat if you feel like not feel talking directly.
Yeah, sure. Yeah, that's a good. Thanks for saying it.
Great session, kind of comments. They all like it.
I'm glad.
Yeah, excellent training.
Thank you, guys. I hope that was helpful. And like you said, we will take it beyond and above these. Any help you need, reach out to Yen. And thanks her once again, for putting this together. I think it was really helpful for you. And I enjoy doing these. This is my passion, and, willing to help anyhow. Next 2 days will be great sessions, hopefully. See you tomorrow then, 2 p.m., right?
Well, Sheikh, thank you so much for a very informative session. And thanks everyone for joining. So we'll see you guys tomorrow. All right.
Sounds good. Everybody
Bye.
have a wonderful night.